Welcome to our session today about seeing threats that others miss. My name is Christopher Martin. I'm VP of Customer Success at VMRay, and I want to talk to you today about how important it is to implement an evasion resistance behavioral analysis platform within your company. When analyzing any type of malware, it's important to understand that you only detect what you see, and you actually only see what you're looking for. So most technologies have specific things they're looking for when they're analyzing a piece of software. So how do you see something that you're not actually looking for? How do you detect unknown malware? Well, what we've noticed is that unknown threats is not really clearly defined, right? You hear a lot of different keywords out there. They range from advanced persistent threats to simply new or zero-day threats. But usually unknown malware is actually known malware from the past that's just been combined with other techniques. It's been modified, polymorphed. Of course, not all unknown threats are known malware. There are real zero-day threats out there. And having an evasion-resistant behavioral analysis also detects these as well. And unknown threats are not only attacking large organizations or governments, they're also targeting small and medium business and also mid-sized and of course large enterprises. And unknown threats often go undetected by traditional detection techniques. Traditional techniques these days, and also in the past, have been utilizing things like signatures. So your typical AV vendor uses this. This has been continued on or enhanced with what we call heuristics. Also, AV vendors use this to go a step further than just basic signature-based detections. There's also unpacking techniques and also machine learning and AI, which are more what we call next-gen detection techniques that go a step further from signatures and add statistical methods after analyzing a multitude of known and also unknown, but also detecting or analyzing, known good or known bad files, and use statistical methods to, detect or suspect whether something is malicious or not. And then there's behavioral analysis. Behavioral analysis is important because it gives you better insight into what's going on. But as you'll notice in just a moment, the other technologies are still important. So signature-based, yes, it detects known threats, doesn't detect variants, doesn't detect unknown threats. But you'll see in just a moment, it's still important technology to keep within your company. Heuristics and unpacking go a step further. They can detect variants of known malware. And the next-gen technologies can detect some unknown threats because they're using statistical methods based off of known good and known bad files. Behavioral analysis gives you but full visibility within what's actually happening. Here, a funneled approach showing you why all these techniques are all necessary and important. So you want to get rid of, the actual known good and bad stuff really at a high level, because dynamic analysis or behavioral analysis is very resource intensive. So you want to utilize reputation-based scoring to get rid of known good and unknown, known good and known bad files right up front. Then utilize static analysis techniques to go further. So instead of just being a hash-based technology that's looking for known good and known bad files based on their hash, look into some more details of the file. Analyze what's actually there using static analysis methods. And only then, when you've used these relatively fast technologies, then utilize dynamic analysis or behavioral analysis to get to the core of things. Analyzing memory dumps and actual network activity, utilizing screenshots to see what the user sees, and actually having a look at dropped files, things that happen while the analysis is going on. So how does behavioral analysis work? Basically, you execute a file or a URL within a secure environment, and while it's executing, you monitor and analyze its behavior. After analyzing its behavior, then you make a decision. Is it malicious or is it not malicious? There's different ways to monitor an execution within a detonation environment. And the most common way is what we call API hooking. So most vendors utilize this technology. It's basically intercepting calls to the system functions. It has advantages. It's easy to implement, and that's why most vendors utilize this technology. And it can be fast, but oftentimes in order to get higher visibility within what's going on, then it actually goes the other way and makes it very slow technology. One of the main drawbacks is that it's easy to detect and it's easy to evade because you're hooking into the same operating system that the malware is running in, so it can detect what's going on. This is just a short example of what it means to do API hooking. There's thousands of APIs within Microsoft's Windows. So making the decision of which APIs to actually hook into and to monitor is a tough decision, because depending on where you make that decision or do your hooking, you may be losing a lot of context into what's going on. Or if you're hooking too much, you're going to slow down the system and also broadening your detection vector, or the vector of being detected and then eventually being evaded by the malware. How VMRay does this is to monitor from outside the system. We monitor the VM from the hypervisor. So we observe the engine running the VM, and that makes us invisible to what's going on within the VM. Advantages are it's very stealthy. We do see every interaction within the system, and it's relatively fast on modern CPUs. Of course, there are drawbacks. It's very hard to implement this type, and that's why most, if not almost all vendors do not choose this method, but VMRay has chosen it, and it's proving as one of the best ways to be evasion resistant and monitor at the same time. This is just a short example of what it means. I mean, if you are integrated within the operating system, you've hooked into the operating system, you are monitoring what a malware potentially does. The malware detects that there's a sandbox agent or hooking within the system, and it changes its behavior, so you don't see the full behavior of what's going on. Being agentless or being outside of the environment makes you completely invisible to the malware. So it cannot detect that you are there and will show its full behavior for you to do your monitoring. When choosing a system that is, that does behavioral analysis in an effective way, then look for a system that gives you full visibility, that shows you full process interactions during execution, and potentially look for one that also supports reboot, because some malware will implement itself in a persistent way and only show its behavior after the system reboots. So choose a system that supports rebooting during analysis. It's also very important that you, as an admin or a malware analyst, see exactly what the user sees, that you can see what's going on the desktop while it's being analyzed. These are screenshots that are shown during an analysis, but you also have the ability to interact with a malware while it's being executed in a secure way. So while an execution goes on, you can do live interaction with the malware while it's being executed. Also look for a system that gives you full visibility, that's not just filtering based on what it's looking for, right? Because that's not much better than a signature-based system. You want a system that gives you full visibility down to the function log. Also, being invisible to the malware by monitoring outside the environment makes you fully invisible, and you can detect evasion attempts much better. Also, a system that is very relevant to your organization is one that gives you the ability to visualize the attack, to see exactly, where is this system communicating with, and how is it evolving over time. When you're looking at a system, what data it provides, then look for one that gives you relevant IOCs. Not just one that export all artifacts, as you can see here in this screenshot. This executable, or this analysis had 411 artifacts, or actually 567 artifacts in total. But we at VMRay allow you to filter out the noise within the IOCs and only export the artifacts that are really relevant to that actual malware, and that makes your existing threat intelligence environment more efficient. Also look for a system that's going to utilize existing frameworks that you utilize within your company. This is an example, MITRE attack matrix. We show how our detection maps out to the MITRE attack matrix. So if you're using MITRE attack with framework within your company, this gives you much value for your other systems. To sum up, visibility is key. It's important when you're implementing a behavioral-based analysis system that it gives you full visibility, that it adds eyes to your existing security infrastructure, that it can add the relevant data to your threat intelligence systems, and that provides you full visibility into unknown threats. So implement evasion-resistant sandboxing when you're looking for a behavioral analysis system that is really relevant to your organization. I want to thank you very much for joining this session. Please visit us at www.vmray.com. Thank you.